So our next polynomial inequalities are going to be higher order degree polynomial examples. So we just need to pay a little bit more careful attention to the multiplicity. So on the first problem, we have x plus 1 times x minus 2 squared plus times x plus 3 quantity squared is greater than 0. Notice I'm only doing one inequality. I could use the same graph to get a whole bunch of different inequalities, but I think we have the point now. So I first want to emphasize that my function is x plus 1 times x minus 2 squared times x plus 3 squared. So if I multiplied out the first terms of all of those, I would get x to the fifth, including my exponents, plus a whole bunch of other things. That will get me my degree, which is 5, which is odd, and my leading coefficient, which is 1 or positive, so my end behavior is down, up. The zeros, I have a 0 and negative 1. I have a 0 at 2, but because of the squared, that gives me a multiplicity of 2. And then I have a 0 at negative 3, which is a multiplicity of 2 as well, because of the exponent. So to graph, I have my zeros, and I know I start low and end high. And let's see, at negative 3, because I have a multiplicity of 2, I'm going to come up and touch and turn around. At 1, I have a multiplicity of 1, so it goes straight through at 1. And then at 2, I have a multiplicity of 2. That means I come, touch it, turn around, and keep going back up. Notice that my end behavior and my multiplicity matched up. Now that I have the graph using the x-intercepts and the end behavior, I'm going to mark the positive and negative values on the graph. So anything that's below the x-axis is going to get me negative values. Anything on the x-axis gets me zeros. I have negatives again, a 0. Then I'm above the x-axis, which gets me positive values, 0 again, and then positive values again. Okay, so let's go back and identify what my inequality am I looking for. I want to know, where is my function f of x greater than 0? Greater than 0. Greater than 0 is positive, but not zeros. So I have positive things right here, but not 0. Positive things right here, but not 0. So in that case, the solution is the x values that give me positive f of x values. So the x values are the domain, starts at negative 1, ends at 2. Now, do I get to include the 0? Well, in this case, no. So I'm using parentheses. Union, then I start again at 2 and go to infinity. Again, you can't include the 2. Let's do the same problem again using the sign test method. So my f of x is the same as the graphing method. Again, I'm also looking for, where is f of x greater than 0. My zeros are the same as well, negative 1, 2, multiplicity 2, and negative 3, multiplicity 2. The multiplicity doesn't matter quite as much on the boundary points. I just have 3 spots on my number line. And now I have a lot of intervals. I've got an interval to the left of 3, negative 3, between negative 3 and negative 1, between negative 1 and 2, and then again between 2 and infinity. That's a lot of intervals that I have to figure out. So that means I have to choose a value in between each one of those intervals. So I have f of something to the left of negative 3, which is, we'll try negative 4. And I'm going to go ahead and plug that in, negative 4 plus 1, negative 4 minus 2 squared, negative 4 plus 3 squared. So that gets me negative 3 times negative 6 squared is positive 36. And negative 1 squared is positive 1. So a negative times a positive, which turns out to be negative 108. But I know it's like a 108, that's large, but the real big thing is that it's negative. Okay, so a negative times a positive is a negative. That's good enough. To the next interval, I have something between negative 3 and negative 1. We'll go with negative 2. Again, this part gets really tedious, so if you like the graphing method, I would suggest you go with the graphing method. So I've got -1 times -4 squared, that's 16, times +1 squared, that's 1, which is also negative. The next interval between -1 and 2, we'll pick 0. 0 plus 1 times 0 minus 2 squared times 0 plus 3 squared, which is 1 times -2 squared is 4 times 3 squared is 9. A positive times a positive times a positive is a positive 36. Most importantly, a positive. And in the last section, anything to the right of 2, we'll try 3. Okay, that gets me 4 times 1 squared is 1 times 3 plus 3 is 6, and 6 squared is 36, and 4 times 1 times 36 is 144, which is positive again. Don't forget that at the zeros you have a 0. It's important because if it's or equal to 0, you might need to include it. If it's not, you have to not include it. The interval that I'm looking for is going to be anything that is greater than 0 but not equal to it. Greater than 0 happens where it's positive. So my solution will be -1 until 2, union 2 to infinity, not including the 0 at either 1, -1, or 2. Again, look at the two examples and see which one makes a little bit more sense to you. I find the graphing method a little bit more intuitive. The sign test method has a lot more tedious work to it. Here's another higher order problem where our f of x is x cubed plus 7x squared minus x minus 7. I need to factor that. So it looks like a grouping problem. I can factor in x squared. And I'm done -1 out of the second group, which gets me x squared minus 1 times x plus 7. And then the x squared minus 1 is a difference of squares. That's x plus 1, x minus 1. All right. That tells me that my zeros are at -1, 1, and -7. Using the original function, my degree is 3, my leading coefficient is 1, there's a 1 in front, with an odd and a positive, it's down to the left and up to the right. I'm going to plot my values of my x-intercepts or my zeros. So I have points here and my end behavior. So there is no multiplicity on this problem, which means I'm just going to go through, and through each one of my x-intercepts here. Now let's go back and mark anything that's below the x-axis is negative, anything that's above the x-axis is positive, and then zeros at my zeros or x-intercepts. The question I'm asking today is, where is my f of x less than or equal to 0? Less than or equal to 0. That's what I'm looking for. So less than or equal to 0 means negative or 0. So include the 0 and negatives. The intervals where that happens, the domain at which satisfies my inequality starts at -infinity and ends here at -7. I get to include the endpoints, so that's a bracket. Union, the next part that's also negative is -1 to 1. Those get brackets because I'm allowed to include my endpoints. Okay, let's do this problem again using the sign test, the same exact problem. So my f of x is the same. Because I just spent some time factoring this, I'm not going to factor that again. If you were to go straight to the sign test and only do the sign test, then you would have to do all that work again, okay? My zeros are -1, +1, and 7, -7. And I have lots of things I need to pick here, don't I? I have lots of intervals. So I'll pick something to the left. I need to pick something to the left of -7. I'll pick -8. Now I could plug this into the original, or I could plug it into the factored. Either one will work. I'm going to go ahead and try the factored just because it looks like it might be a little bit easier on me. So this gets me -7 times -9 times -1. Okay, the most important part is that it have 3 negatives, which is going to get you an answer of negative something. In this case, it's -63. But the fact is that it's negative, so the whole thing is negative, okay? All right, let's look at the next one. So I need a point in between -7 and -1, which is, I don't know, let's try -2. Again, I'm going to use the factored form, as long as I'm confident I factored that correctly. This is going to get me -1 times -3 times 5. So that gets me a +15. In the next interval, between -1 and +1, I'm going to try 0. When I multiply that out, I'm getting 1 times -1 times +7, which is -7. And the last one, I need something to the right of 1. We'll pick 2. So that's 3 times 1 times 9, which is 27. But the most important part is that it's positive. Don't forget we have zeros on the x-intercept here. And my question is, where is my function less than 0? That's what I'm looking for, less than 0. Okay, or equal to. That's so negative things or 0, 0 and negative things. So I have 2 intervals. My solution will be -∞ up until -7 bracket, union bracket, -1 to 1. Notice the same problem, same solution, different work to get the answer.